Her eyes adjust to the bright lights, her ears tune in to the sound of the waves, her nose smells the saline air, and this sea turtle hatchling begins a long journey into the ocean. A Florida loggerhead will head east to the Gulf Stream so she can join the circular current system that flows around the Sargasso Sea. She will spend a few years there and then head for the US East Coast. In 35 years, when she is finally mature, she will mate. Then she will return to the same beach where she was born to lay her eggs. But after so many years of travel, how does she manage to return to the same beach she was born? This miraculous phenomenon has beguiled scientists for years, and today we may have an explanation. Sea turtles are one of Earth's most ancient creatures. They have swum in our oceans for more than 220 million years. The current thinking is that sea turtles perceive the Earth's magnetic field like a sixth sense for navigation. Lohmann et al. Tested this hypothesis by capturing green sea turtles from coastal feeding grounds in Florida. They were moved to an outdoor test site where they were subjected to magnetic fields equivalent to those at Site 1 and Site 2. The experiment showed that turtles responded by orienting in a direction that would have led them towards the capture site. This indicated that sea turtles have a magnetic map sense. Other studies have also found that sea turtles can detect the inclination angles of the Earth's magnetic field. The usage of Earth's magnetic field for navigation is known as magnetoreception. It allows sea turtles to obtain directional and positional information about their location. There are two main hypotheses that explain this. The first view is that some organisms have the ability to see the Earth's magnetic field. Cryptochrome is a magnetic molecule found in the eyes of sea turtles. When exposed to a photon of light, it produces radical pairs. Radicals are molecules that have an odd number of electrons that can exist in two spin states, the singlet state or the triplet state. The external magnetic field affects the interconversion between these two states, and the ratio of radicals in different states induces signals that the animal can use to recognize the direction they need to go. The second view is that biogenic magnetite or iron oxide crystals found in the beaks of birds and in sea turtles is responsible for magnetoreception. It has strong magnetism, and coupled with the nervous system, it could help sense direction, polarity, and magnitude of the ambient magnetic field. There may also be other sensory inputs that allow sea turtles to imprint specific geomagnetic signatures of nesting sites. These could be the smell of seabirds or landmarks like sea mountains. There is still so much to be learned about this navigation sense that sea turtles possess, and as we approach the answer, we may uncover one of the coolest feats of the natural world, and maybe even chance upon ingenious navigation methods to integrate into our own technology.